All right, so we have chemical properties. With chemical properties, there's combustibility, there's reactivity, there's flammability. Those are all chemical properties. All right, and this is chapter 5, lesson 2. Now, chemical properties, if you look down here in the bottom left, how the subs react in the presence of air and acid and water. And when they say subs, they mean substances. All right, so it's how things react when they're introduced to new stuff. All right. So common ones, common things that you'll see here are those items that I'm showing you right now.
That's all today?
Mm-hmm. All right. So the combustibility. So we see the ability to combust or spontaneously spark into flame. Reactivity with water, like we see with the nails or the Alka-Seltzer, with light, like we see with the film. All right, or flammability, that ability to burn. All right, combustibility is different. Burn in without a flame source. Flammability, there needs to be a flame. So, common chemical properties. All right, we see nitrogen up here. We'll talk about why that's important. Combustibility and flammability, I put them together because they're the ability to burn or the inability to burn. Water will not burn no matter what we do to it. It will just change to a vaporized state. And many of you talked about that in your video reviews yesterday. Wood will burn. There are other things that will burn. Another thing like plastic won't burn, it will melt and then it will vaporize before it burns. So, those are all things that um, can happen. I'm sorry, I'm a little bit distracted. I'm trying to get Cassidy on the chapel. All right, so common chemical properties, combustibility and flammability, the ability to burn or not to burn. All right, so that is a chemical property that something will have because it's the way it reacts to a flame or a heat source. All right, then other common chemical properties, the reactivity. So we can see iron. You see the nail over here way on the left. All right, when it reacts with oxygen and or water, we get that rust. We see Alka-Seltzer. When it gets into the H2O, there is a reaction that's taking place that allows this to happen. And if I'm right, Sam, you did this a while back. Alka-Seltzer and water is a chemical reaction, right? Or maybe that was Riker. I couldn't believe it. I remember somebody did it, but that is a chemical reaction. Sodium. Sodium is a silvery metal, and you can see the part by the knife there. It's really silvery, but it reacts very quickly with oxygen and creates that coating, that corrosion. What was that called? That patina, somebody said. An apple, when you cut it, it's white. When you leave it be, the oxygen reacts with it, and you get that rust look thing. Gold. Gold is something that doesn't have that reactivity, is able to fend off that air. It doesn't react with oxygen. Okay. Now, sodium, this is a video here. I do believe that when we click on it, we'll see if my computer can handle all this. Yes, we're going to see how it reacts with water. You can see it like on top, and literally it's buzzing around and bursts into flame because those vapors that are coming off of it. It's that reactive with water. Okay, so you can watch that in full in a bit. I will add that as well. All right, so we move onward and upward. Common chemical properties, the ability to react or not react with oxygen. So, apples, nails, Alka-Seltzer, because that's reacting with the oxygen in there. Sodium, all react with it. Gold does not react with it. Okay, so ladies and gentlemen, okay, all right, those are the chemical properties for the reaction with oxygen. So we looked at how it reacts to flame, we looked at how it reacts to oxygen, we're going to look at how it reacts to another thing here. Iron, they react. Apples, they react with oxygen. Sodium, they react with oxygen. Gold does not. All right. So all those things that react or do not react. Okay. As we move onward, the ability to react or not react with water. We'll do arrows again. Okay, so sodium does react with water. You saw it sitting on top and burning, had a violent reaction. All right, we see Alka-Seltzer, it reacts with water. We see iron, it reacts with water. And gold does not react with water. All right, if you would put an apple in water, you'll actually see it turn brown as well. Okay, so the ability to react or not react with water or with oxygen, those are the things that we're looking at today. All right, chemicals of properties, we're going to look at acids and bases. All right, they're side by side, so they are compared. All right, acids, they react with bases. Bases, they react with acids. All right, hopefully that's not a surprise to you. All right, with bases, we can see the corrosive, it reacts with the water, the H2O, and you can see maybe a battery that's corroded before. Okay, corrosive reacts with H2O, tomato sauce, and aluminum foil, so it may react with other forms as well, but the moisture in there reacts and causes a rust or other things to happen. All right, so if you ever cover your plate of spaghetti sauce with aluminum foil, you might get this reaction that's down here at the bottom. Okay, so a corrosive reaction. Corrosive is a word that means to corrode or tear away small bits and pieces as it goes. All right, they're dangerous. Bases are, because it reacts with the water. Your body is made of like up to 70% water. The ammonia, now that's not the ammonia that's you're cleaning with. That's like a 3% solution. So that's 97% water and 3% ammonia. But you can get it in higher doses. That can burn skin, burn hands. All right. Dangerous. They react with the H2O in your skin. Now, your urine has acid, it's got an acidic content to it, and that's why babies get diaper rash. You can see the little diaper rash that I gave the baby here. All right, because when they go to the bathroom in their diaper, that urine sits there, the urine reacts with the acid in the urine reacts with the skin and causes that rash. That's why it's a need to change them quickly, and there's laws and daycares and those different things that diapers have to be changed every so many um, minutes. I think it's like 90 or 100 minutes, whether they're wet or not. All right. Now, these are common acids and bases, but I do want you to notice acids are corrosive and dangerous, bases are corrosive and dangerous. Both will be if they're um, highly acidic or highly basic. All right. So, common ones that we might have in the house. I'm giving you these to help you with homework. All right. Acids, vinegar, aspirin, citrus fruits, tomatoes. So, this would be a good time, like Lucas said, take a picture of the page. Carbonated drinks like your soda, your beer, any of those different things. All right. Stomach acids are some of the stronger acids that we have. Our stomach acids are around 3.5. That's why the lining in your stomach's there. So, you can see all the common acids on the left. And then on the right, you have things like deodorant, antacids, drain cleaner, soaps, baking soda is a base. Okay? So all these things are common bases you might see in your home. All right? When acids and bases mix, something happens. Now, this white here, I'm going to just take a chance. What do you think that white there is? Anybody got a guess? Salt. Oh, Lucas is on top of it. He watched a video about this yesterday. Good job, Lucas. All right, with salt. All right, when acids and bases mix, you get salt. All right, salt is created, and there's also water created. So you know when you put together the what is it where the volcanoes explode and do those other things? That's baking soda and vinegar, right? Now, have you ever noticed that there's that crumbly stuff? If you move it around enough, you do have salt created. Both of those are relatively weak acids and bases, so you don't have as much salt. But here's kind of how that happens. You have hydrochloric acid. That's what they're using out here. All right, HCl, hydrochloric acid. And then you add NaOH, which is sodium hydroxide. It's a salt. All right. And that gives us water. You see all the clear stuff down here? That's water that's being siphoned off. And sodium chloride. The, let me draw. I like to draw. The Na and the Cl, there was one of each, and they come together to make one sodium chloride. There's one H, two H's, and an O, just one O, they come together to make the water. And that's how that reaction works. Okay? So salt is created, and there's a chemical reaction of it. Those two things going together. The arrow here means that energy is created or destroyed. All right? So now we look at these two solutions. All right? I've got these two solutions, and I'm going to drop the same thing into both of them. When I do, they turn different colors. What does that likely indicate then? Bueller? Bueller. Somebody, what does it likely indicate, guys? So, all right. So I've got the same liquid up here at the top. All right, let me get my laser pointer going. Got the same liquid up here at the top. The same liquids in both eyedroppers. I dropped it into two substances that looked like they were the same. But after I dropped it in, the substances turned different colors. What does that mean about the substances? They are different. All right. So, what we have here is we have an unknown liquid. Okay. The unknown liquid is in the jar. We drop a known base into one cup and a known acid into the other cup. All right. What is the unknown unknown base or the unknown liquid? Is it an acid or a base? So we're dropping an acid into this side. We're dropping a base into this side. The unknown liquid, both liquids in both containers are the same thing. Okay? So here's what happens. When we drop the base in, when we drop the acid in. So this unknown liquid, we dropped the base in and that happened. We dropped the acid in and nothing happened. Was this unknown an acid or a base? What do you think? Acid. Why do you say acid, Blake? And what do you think that white stuff on the cup is, Blake? Salt. And then with an acid, it didn't react, so it's there. And here's why. Let's see how Blake did. An unknown is an acid because when the base was added, it created salt. All right. Very good. Very good. Do you guys see what Blake saw? I hope so. All right. That is all I've got for you today. I'm going to stop